So we left off getting ready to talk about decomposing functions. And we had just been working on composing functions. So our fog and golf, we're doing f of g of x. Taking a function, putting it into another function. Now we're going to decompose. So they're going to give us, they're calling them h of x. But h of x is defined as f of g of x. Okay? And we're being asked, okay, what is f? What is g? So looking at h here, the easiest thing to do is to look for something that we could call the inside function. And in this case, by this definition, g is our inside function. So I'm looking for something that I can call g of x. And then f of x, I guess I'll write this up above. Didn't really leave myself great room there. F of x will be the outside function. So after you pull the insides out, what remains? So thoughts on what we could use for the inside function? What do you think?
Plus 1.
X plus 1, do you guys see it? That's the obvious one that I would say. And I will say, there are times there's more than one right answer. But I definitely here would say that g of x is x plus 1. Now, if that's your inside, you're going to pull that piece out, and what remains in place of that piece is just a plain old x. Okay, so if I pull the x plus 1s out, and then in place of them is just a basic x, what is that equation, what is f going to look like? What is f going to look like? What do you think, Katie?
X squared minus 3x plus 4.
Okay. X squared minus 3x plus 4. That is what we would call our f of x. Okay. And that's I will say on this one, that's the only answer I see. I'm not going to say someone couldn't come up with something else creative here, but that's the answer I see. So each time there was an x plus 1, pull the x plus 1 out, and it's just now an x. So it's x plus 1 squared. Now it's x squared. It was minus 3 times x plus 1. Now it's minus 3 times x. And then it's still plus 4. Okay? Want to try the next one? Okay, so here's what I'm going to say. Before anyone says anything else out loud, you think about the next one. Okay, we're looking for an inside g of x and an outside f of x. So I'm looking for g of x, what I think g of x could be, and then what I think f of x could be. You have your guess?
Yes. I'm ready.
So what kind of guess do we want, or thoughts do we have for g of x? So the inside function here. What are you going to say, Stetson?
X cubed plus 1.
Okay. If we say g of x is x cubed plus 1, what does that have to make f of x?
Square root of x.
Square root of x? Because if I take that x cubed plus 1 out, and it's just now an x, that is the square root of x. And here's the deal. Can you try and recompose it and see if it still works? You should be able to. So if that's how on a test, that's how I'll test your solutions. If you don't match my answer key, I'll test your solution and see if it comes back together right. So if I'm trying to find f of g of x and I take g and put it in f, that works. Okay, now, that is an answer. That's the answer I see, I'll be honest. Anyone have thoughts on another answer?
No, that's good. No.
Okay.
Maybe 8.
I mean, here, and the only reason I ask is that there's not just one right answer on these, and that's what you have to understand. Okay?
Could you say, like, x cubed is the inside?
You couldn't.
X plus 1 under the square root?
Mm-hmm.
Oh.
So, in case anyone out there is being shy and saying, well, mine didn't agree with theirs, mine was wrong, okay? I sometimes will have people say, okay, I'm going to say I saw g of x being x cubed. So just the x cubed. If we do that, then okay, pull the x cubed out, replace it with just a plain x, and now it is square root of x plus 1. That's a very valid answer, equally correct answer.
No way.
Okay. So now you can't mix and match. You can't pick this g of x and that f of x. They go together as a pair, right? But that is another valid answer. So I don't want you to think, well, mine didn't agree with theirs, mine is wrong. It could. Now, there are wrong answers also. Okay. But it is possible for multiple right answers. Got it? Okay. Let's talk about the backside. In the medical procedure, angioplasty, a catheter is inserted into a heart vein in order to inflate a small spherical balloon. Suppose the balloon inflated at a constant rate of 44 cubic millimeters per second. And we have 3 parts here. Okay. So A, find the volume after t seconds. So think about the information they give us. And we're being asked to find the volume after t seconds. What information do they tell me about volume? What do we know?
44 millimeters cubed per second.
Okay. And we know 44 millimeters cubed is volume because it has the label of cubed, right? Power of 3, that's our volume. So right there, that's what they tell us. That the balloon inflates at 44 cubic millimeters per second. We're being asked to find the volume after t seconds.
Solve for T.
I don't have anything I can solve for t, though.
Is it just 44 millimeters cubed T?
Mm-hmm.
What?
I tell you, I'm
Okay.
on it today.
That's a lot.
Okay, so let me back that up. Let's bits and pieces here. What can you tell me after 1 second?
It is 44 millimeters cubed.
Can we agree that the volume after 1 second is 44 cubic millimeters? Yes? Okay. What can you tell me after 2 seconds?
It's 88 millimeters cubed.
It's 88 because 44 times 2 is 88. Are you following here?
Yes.
So what would you tell me after 3 seconds?
132 millimeters.
Okay. And I was going to say whatever 44 times 3 is, yes? Okay. He's on it today. He's got the numbers for us. He's got the stuff. Now, this is after t seconds. So it's not 1 second, it's not 2 seconds, it's not 3 seconds, it's t. So how are we going to express that? That is 44 times t. Since it asks us to find the volume, I put V equals 44t. Because that could be for any number of seconds. Did I break it down enough? We're good now?
Yes.
Oh, wait.
As opposed to Stetson's random first answer of 44t that some of you said, what?
Hey, it was right though.
It was right. I agree. And I'll take it. Doesn't mean I can just move on. I still have to explain, right? Okay. When the volume is V, what is the radius?
22.
Oh. Wait, that kind of makes sense. Well, no.
Wait, is it actually 22?
No.
Oh, okay.
It's actually a formula.
Oh. I'm right.
Because they don't give us at a specific time or value or anything like that. Just in general, when the volume is V, what is the radius? Now, we need to talk about a formula that relates volume and radius. We need a formula that relates volume and radius. What?
circumference, diameters.
She's throwing out random words.
Pi r squared. We're on the right track.
Okay, well, I need volume. Now, let's back up here for a moment. What shape are we talking about?
A balloon, a circle.
Okay, it did say a spherical balloon, yes?
Circle.
So, circle is our 2D version. What's a balloon?
Sphere is a
A sphere is our 3D version, right? Okay, yeah. A ball, right? A balloon.
Oh.
Except a round balloon. It can't be oblong. We're talking a round balloon here. So, what is our formula for volume of a sphere?
Does it have something?
Nope.
See, I don't remember.
I don't know if you guys, I can guarantee you've seen volume of a sphere. Whether you remember it, it's a whole nother ballpark. Oh, she's pulling out glasses. I think there's one year I had somebody pull out some notes from Doc's class or something. I don't know what, I don't even remember what class it was, but they had some class that.
That's fair. That's
You're assuming I
We
spelled it right.
decided today that Emma can't actually see what Trent looks like.
That's why
He's
we're
too
neighbors.
high up there. He's like just in the clouds. So she just likes to wait. She beats.
I like the idea.
Yeah.
I can't even compete with that, guys. I got nothing there. Okay, volume of a sphere. We're talking volume.
is there pi? Is pi in there?
Pi is in there.
All right. Is there?
And radius.
We've got a radius there.
Diameter.
A square of it?
No.
We're putting radius, we're not putting diameter.
We're squaring something.
No, I think we're
Cube.
too big.
There's a cube because we're talking about volume.
Okay. Yes.
Pi r cubed.
Are we cube rooting something? Oh, darn
And I left a gap.
T.
No.
T.
There's a fractional value out front.
1/4.
1/3.
1/3.
Oh, 4/3. This.
I got nothing here. Okay, so
Come on.
a formula you should be familiar with is volume of a sphere, which is V equals 4/3 pi r cubed. Our question asks, what is the volume, or when volume is V, what is the radius? We need to take this equation and solve for R. I want to know what is R in terms of V. So how would you like to solve for R?
Well,
Plug 44 in for B. For R.
what? No.
Nothing right now.
No.
Oh,
Save that thought for later on.
Wait.
Save that for Percy.
You said it's just an equation. didn't you?
It is just an equation.
Oh.
It says what is the radius. So I'm looking to get
R equals.
R equals. So take this equation and solve it for R. 4/3 needs to move to the other side. Is that what you said? How could I move that 4/3 to the other side?
Subtract it.
Divide it.
Divide
Multiply it. Multiply it.
Do the reciprocal.
oh,
We-
she's
hey,
so
look,
smart.
we were there.
Multiply by the reciprocal. This is a very big group effort this morning. Ooh, okay, so in order to get rid of a fraction that is being multiplied, easiest thing I would say is multiply by the reciprocal. Reciprocal of 4/3 is
3/4.
3/4. What I multiply the right by?
Multiply the left.
We're going to multiply the left by. I guess we could have done that differently, but that's all right. 3/4 times V.
3/4 3.
3/4 V, or I'm actually going to write mine as 3V over 4.
I don't.
It is also 3/4 V. Okay. 3/4 times 4/3 cancel, and I'm left with
Pi r cubed.
pi r cubed.
Can you subtract pi? Is that a thing?
We're not going to subtract pi because it's not being added.
But is that a thing?
It's dividing.
It could be.
If they're smushed together.
You can have negative pi.
Okay. Now, pi is being multiplied, so we can think of it as dividing by pi. I can also, because I already have a fraction over here, dividing by pi
Put pi in the denominator.
pi is going to go in the denominator, right? So I'm going to actually write this as multiplying by 1 over pi. Multiplying by 1 over pi is the same thing as dividing by pi. You with me there? So now, 1 over pi times 3v over 4 is going to become 3v equals 4. 3v over 4 pi equals r cubed. How do we solve for r if it's r to the third? We are going to cube root. If we cube root one side, we cube root the other side. We end up with r equals the cube root of 3v over 4 pi.
Nice.
So that answers the question of when the volume is v, what is the radius r? So it was finding the equation that relates volume and radius in the scenario and solving it for r because it says what is the radius. Okay, now A and B were important to part C. Part C says write an equation that gives the radius r as a function of time t. What is the radius after 5 seconds? So hold that thought. What is the radius after 5 seconds? Hold that thought for later. Write an equation that gives the radius r as a function of time t. What formula, what equation do we have for r right now? We know r as the cube root of 3v over 4 pi, right?
Yep.
That is from the previous problem. Now, it said write an equation that gives the radius r as a function of time t. Folks, right now I have r equals, and this is a function of what variable?
T.
No, it has a v in it. Okay, so right now we have r as a function of v. I want r to be a function of t. What connection do we have between v and t?
44t.
V is 44t. So I can rewrite r is the cube root. Instead of 3v, I'm going to say 3 times 44t over 4 pi.
Wait. 44?
4 pi. My apologies. I wrote 4 pi. I just said the wrong thing. Now, you can multiply and then simplify. Or me personally, I'm going to simplify right now, and then I don't even have to pick up my calculator.
Well, I like
What can I simplify right now and not have to grab my calculator?
fours.
My 4s, yes. Do you see that? Now, I'm not saying it's wrong if you did it the other way. You're just going to have to catch to simplify. I personally see that 4 divides by 4 to be 1. 44 divides by 4 to be 11. So then I'm never grabbing my calculator. And I know that on top, 3 times 11t is going to be 33t over
Pi.
pi. All under the cube root.
And what about the pi?
So now you just plug in 5 to t.
That's the other part.
Oh.
Yeah. So, okay. Some of you, okay. So I was taking this as a 2-part question. Part 1. Write an equation that gives the radius r as a function of time t. That's that. Part 2, what is the radius after 5 seconds? So now, yes, we are plugging in the 5.
That's right.
You were skipping over the initial.
Yeah.
So r equals the cube root of 33 times 5 over pi. And that is definitely a calculator problem.
165.
Is that what 33 times 5 is? Okay?
I need 44 times 5.
Yeah, it's 160.
It was 220.
Then you're just going to have to divide by 4 pi.
How do you get a cube root?
If it's not a second function, it's in the math menu. When you hit math, it's on that very front screen, isn't it? Oh, it's also up in alpha F2, I believe. Okay. So yeah, I'm spouting off ways to find cube roots. Okay, you guys getting something on the calculator?
Oh, goodness.
I just have the final answer is what I have.
Like a number? Just one number. 3.745.
Yeah. I have written down that the calculator comes out to be 3.744938504, but I actually have my final answer rounded to 2 decimal places. So 3.74, what kind of label?
Millimeters.
So radius,
Cubed.
so it's just millimeters. It's not volume, so it's not cubed anymore.
I was seeing if you were going to
Number
catch me.
31 is this.
Probably.
God.
Caitlin has a good point, guys. 31, what are you probably doing? This type of stuff. I don't remember off the top of my head, I'll be honest, but I'll check here in a moment. Okay, you have some work time. Use it.